and then if any rotation happens and it moves, it will not just pop out. Additionally, we have these 4 legs on the bottom that are pretty thick, around 4 different screws onto the rotator, so everything is able to rotate as one piece instead of having any disturbance. And the specific design of what we had across is mainly for convenience. As you will see later in the video, we will have to rotate the antenna.
So the receive antenna is just a simple 2x2 patch antenna array. In the design phase, it was designed for 2.45 gigahertz operation, but upon printing it and receiving it, operation at 2.41, which matches up with our bandpass filter. So we'll be transmitting and receiving at 2.41 gigahertz, which will be the operating frequency of the system.
So once the signal leaves our scan, it goes directly into another bandpass filter designed by Sharon here, which then goes to I believe the PGA 105 plus or the CMA 103 plus. I forget which one. It's our low noise amplifier. We're getting another 10 to 15 dB of gain before going into the I input of our demodulator. Or excuse me, our RF input of our demodulator, which separates it out into the I and Q signals. The Q signals left alone. Our I signal then goes to the ADC on our STM32 microcontroller. Additionally, this STM32 microcontroller also has some cables going to a separator motor driver, which then allows us to rotate the angle of our antenna system. And how we kind of have the MATLAB code set up right now is upon startup, when we let it know we're ready to go, it's gonna take 1,000 measurements at about a 4 megahertz sample rate. And from there, it's gonna kind of calculate out like our average ADC value to some DC offset. And then it's gonna increment the motor another 5 degrees, take another set of snapshots, repeat that whole process again for 360 degrees. And then like Sharon said, once we've done a full rotation, we're gonna rotate it 90 degrees this way so that we can measure the other plane, and we go another 360 degrees, taking our sample rate, our samples every 5 degrees. And in real time, while that's happening on MATLAB, we're gonna be plotting out what our actual antenna pattern looks like.